to differentiate e to the 5x sine 3x, we need to use integration by parts. Let's just remind ourselves what that is. We've got the integral of u dv dx is equal to uv minus the integral of v du dx. So we're going to let u equal e to the 5x and dv dx equal sine 3x. If we differentiate u with respect to x, we get du dx is equal to 5e to the 5x. If we integrate sine x, we're going to get minus cos x, but because it's a function of a function, we need to divide by 3. So the integral of dv dx gives us minus cos 3x over 3. So first of all, we want uv. So uv is equal to e to the 5x times minus cos 3x over 3. So e to the 5x minus cos x over 3. And that's going to be minus the integral of v du dx. So we've got 5e to the 5x, which is there, and we've got minus cos 3x over 3, which is there, dx. So we've got 5 over 3 e to the 5x cos 3x dx. Now we're going to call this integral I1. So we'll let u1 equal e to the 5x and dv1 dx equal to cos to the 3x. So the differential of u1 is going to be du1 dx is equal to 5e to the 5x, and the integral of cos 3x is going to be sine 3x over 3. So I1 equals uv, u is e to the 5x sine 3x over 3, minus v, which is the sine x there, du, 5e to the 5x, which is there. Let's clear some space. So that's I, and this is the bit that we called I1. I1 is given by this expression. So now we want to substitute I1 into there. 5 and 3 are constants, so we'll take them outside the integration sign. And we notice that we've got e to the 5x times sine 3x, e to the 5x sine 3x, which means that this is equal to I. So we can substitute that into the expression. So I1 is equal to e to the 5x sine 3x over 3 minus 5/3 of I. So now what we want to do is to substitute I1 into here. So I is equal to minus e to the 5x cos 3x over 3 plus 5/3 brackets e to the 5x sine 3x over 3 minus 5 over 3i. So now I'm going to take this part onto the left hand side, but I've got 5 over 3 here and 5 over 3 here, which mean, and this is minus. So when that goes onto this side, it's going to become plus 25 over 9 times I. And that is equal to, now let's simplify the right hand side a little bit. I've got e to the 5x in the cos term and e to the 5x in the sine term. I've got a 3 here and a 3 here, but I've also got a 3 here. So what I'm going to do is I'm going to take e to the 5x over 9 outside a bracket. So I get e to the 5x over 9, and I'll put the sine term first because it's positive and the cos term is negative. And there's a 5 here which comes to the 5 sine there, and because I've taken 9 outside, I need to put a 3 in with the cos. If you're not sure about this, expand the bracket and make sure that this line is the same as this line. Okay, next thing I need to do is to rationalise this. So I'm going to put this over a common denominator, which is 9. So I'm going to get 9 plus 25, which is 34 over 9, giving me 34i over 9 is equal to the right hand side. I'm going to multiply both sides by 9 to get rid of those, and then I'm going to divide both sides by 34 to get rid of that, giving me I is equal to e to the 5x over 34, 5 sine x minus 3 cos x. And just to complete this, we need to add a constant of integration, and that's our answer.